So come on in here and see if we can squeeze. That's pretty cool, huh? So this gets rid of the mule that had to lower the handbasket, or the man that was doing the handbasket lowering, men, I should say. So to hell in a handbasket's no longer. Now it's become a hoist basket, so it's to hell in a hoist basket instead. So you basically be lowered down there. Each one of these bull wheels weighs 450 pounds. It comes to us in 1896. It presents a lot of solutions for all the problems that we face. But also presents a lot of challenges when it gets here. First of all, it's a combustion engine, 1896. They didn't send a sales rep to put it together and say, hey, here's your machine. How do you like it? It was disassembled when it got here. It took a long time for it to get here. Then it was reassembled after being in an ore car. It got to this point, it was put on a foundation, and then it would be reassembled. So like your IKEA furniture today, it comes in Swiss. Same here. They're just instructions were probably very primitive and very hard to do. So somebody had to put this together, then it had to run on something. Well, we didn't have refined gasoline. There was no Carson, California in 1870, so we made our own. We would take the shale. It would be a crude shale. You can tell by the way the liquid looks in here. It's almost like an oil. So it's if you've ever seen Beverly Hillbillies, you'll see that crude West Texas crude blow up through the earth. That's what this ran on. So you can only imagine it burned very hot and very dirty. Secondly, they didn't know about carbon monoxide poisoning. So you burn a combustion engine inside a house for 20 years. I think they did that without ventilation. Finally, we dug a ventilation shaft up there about 1910. I think it was 1896 to 1910. So up there we have a small ventilation shaft. Still not enough. It was enough for the smoke to rise and, roil a little bit or boil, but the smoke just stayed here. And as you can tell, the combustion and all the carbon has now contaminated our quartz. So especially right here. None of this quartz can be harvested because it's too hard to extract gold from a 3-inch carbon contaminated piece of quartz. It would literally gum up the works. It's an oily substance. You need detergent, basically, like a borax, to mix with it. Very difficult. So here this quartz schist stays, and we've got plenty of gold in it. Will never, ever, ever be mined, and it wasn't because of the contamination. So here's the part where you see this big hole. If you took all these mountains away, you would have a quartz schist right there. It would be translucent, not exposed to a lot of moisture. So if you looked at this and took the mountains away at an opposite formation, imagine the Empire State Building just being a big, sheer spire of quartz. That's basically what it looks like when this is full and you took the mountains away. So all this quartz was harvested out of here, and afterwards it gave you a great geology lesson. You can see the east to west. Everything goes east to west. That's the whole Cuyamaca mountain range. It all leans like this. The reason for that is this seabed right here that's now vertical used to be horizontal 2 to 3 million years ago. It was flat from behind the Salton Sea all the way to San Diego. The Pacific tectonic plate rises like this. The Julian schist and the Lake Elsinore fault come up like this. Boom. And we have a major tectonic event. Now, it's not the Sierra Nevadas and it's not the Rocky Mountains, but it's still pretty significant to produce 6,000-foot mountains at Palomar and Mount Laguna. So it goes from Hemet to the Mexican border, rises up like this. Now, just like Hawaii, where the lava tubes are, that's the newest land formation on Earth. That was what was going on here. This is ancient seabed. So this ancient seabed rises up violently and cools immediately because it's full of moisture and it's full of organic material. All your base metals, like our panning exercise, stay down here. And because copper is melts at 2360 degrees, it stays molten longer. So by staying molten longer, all your base metals are now down here, still molten in magma. What happens is they have to exhaust during another violent eruption or tectonic event, and boom, they fill those fissures. That's why you see such defined fissures. And that's why the early miners knew that the base metals were only contained in the quartz. that there wouldn't be anything valuable in the seabed, or very little value in the seabed. Later on, we find out that this seabed is very valuable because it eventually turns into shale, and shale turns to oil. So anything organic will eventually become oil. Again, 2 to 3 million years for that. And then if we wait for that oil just to set, that'll turn into coal. And then we wait another 2 to 3 million years, that coal will turn to diamonds. So this would be a diamond mine in about 10 million years. So I'll see you guys in 10 million years, and we'll all get together and harvest diamonds. So again, you'll see a perfect example of the seabed floor here is the sea salt. That sea salt's first human eyes to ever see it was this year. That came through with the moisture of the rain. Each rainy season we get a little more. You also see sea salt in the shale here. And if you look carefully, you'll see where the moisture's run down here this year. And all the iron in the seabed has rusted. So this is all rust on the iron. And then eventually, where the runoff is, kind of like the Salton Sea and the Colorado River, you go out here, it dries up, and it leaves a salt residue right down the wall. Pretty neat. So